Hi there, Mr. Sutton here with the AB Calculus 6-7 classwork solutions on total distance. For this problem, we have a particle moving on the x-axis with a velocity given by this function here. We're told at time 0, our particle is at position x equals 1, and we want the total distance traveled by the particle from time 0 to time 4. So it's kind of interesting they gave us this initial position because you don't need to know that in order to figure out total distance. If you have a calculator, you can just take the integral of the absolute value of velocity over your time period, and that will give you the total distance. So we're going to have the integral from 0 to 4 of absolute value v of t dt, and let's do that on the calculator now. So I'll start by entering my velocity function in my y equals. Quitting out of that now, I'll do a little Math 9 action. I need the integral from 0 to 4 of absolute velocity, so absolute value of velocity. So I'll do alpha window to pull up this little menu, absolute value, and then alpha trace to get my y equals back, my y1, dx, and just press enter and watch the magic. Working, thinking. Dum-to-dum. Okay, 1.821. So that's answer choice D. On this problem, we're given the velocity of a particle moving along the x-axis with this v of t function, and we want the total distance traveled by our particle from time 0 to time 2. So for total distance, we just take the integral of absolute value of velocity, so basically the integral of speed. So we're going to have the integral from 0 to 2 of v of t dt in absolute value. Let me do that on the calculator now. I'll start by entering my function as my y1, y equals. Not necessary, but it helps. So now we have the integral from 0 to 2 of absolute value of y1 dx, which gives us approximately, drum roll, 2.539. So that's going to be choice D. On this problem, we have a particle moving along the x-axis with a velocity given by this little polynomial. If the position of the particle is 2 at time 0, we want the position at time 1. So since we have an initial position and the derivative of position, essentially x prime here, v of t, we're just going to use the fundamental theorem on this one. So I can say x of 1 is going to be equal to x of 0, which is just 2, plus the integral from 0 to 1 of my velocity function. So what is that integral? Well, this is a no calculator problem, so I need to find the antiderivative and evaluate at the limits of integration. So let's see here. We've got, this bumps up to a 3 for the exponent. Divide by 3, we've got t cubed. And then the other piece of this, 6t, that's going to become, let's see, 3t squared, evaluated from 0 to 1. So I've got 2 plus all this stuff with 1 plugged in, minus all this stuff with 0 plugged in. Well, that stuff with 0 plugged in is just 0. So we just have 2 plus, let's see, this is 4. So that gives us 6. Answer choice B. For this problem, we have a particle moving on the x-axis with a velocity of 6t minus t squared. We want the total distance traveled by the particle from time 0 to time 3. Now, if this were a calculator question, I would just do integral from 0 to 3 of the absolute value of this velocity function and call it a day. Since it's not a calculator question, I'm going to have to take care of all the making negative stuff positive stuff on my own. So I need to figure out if my velocity has any critical values on the interval from 0 to 3. I need to know if their direction changes, so I know when I'm going to have to turn negative area into positive area. So let me start by setting my velocity equal to 0 and factoring. I can take out a t to start with here. So that leaves me with 6 minus t inside, and I have two critical values at 0 and 6. Now the good news is neither of these is on the interval from 0 to 3, at least not between 0 and 3. So what this means is there are no direction changes because there are no critical values on the interval. So that means I can actually just go ahead and take the integral from 0 to 3 of my velocity, and whatever it gives me is going to be the total distance traveled. I mean, we might need to make it positive if the whole thing turns out negative, but that's an easy fix. We don't have to stop halfway on this interval and make some things positive that would have been negative. So I need the integral then from 0 to 3 of 6t minus t squared dt. Taking my antiderivative, I've got, this will be 2t squared minus, this is 1/3 t squared. Evaluating that from 0 to 3, we have all this stuff with 3 plugged in, minus all this stuff with 0 plugged in. Now the good news on this is that all this stuff with 0 just comes out to 0, so it's really this first bracket we have to look at. This is going to be 27 minus, let's see, 1/3 of 27 is 9, so 27 minus 9, which comes out to 18, and that's going to be choice D. On this problem, we have two runners, A and B, on a straight racetrack from 0 to 10 seconds. This graph here shows us the velocity of runner A, and the velocity of runner B, in case you were wondering, is given by this v of t function right here. And this is a calculator problem, so we're going to need to use that for this piece of it. But they want the total distance run by runners A and B over the interval from 0 to 10 seconds. Well, let's start with runner A, because we've got a graph of runner A's velocity. So to find the total distance, we just need the absolute value of the velocity, which is to say the absolute value of the area between this curve and the x-axis. Since this is all positive area anyway, we just need to find the area under this trapezoid. So that's going to be, let's see, we have a base of 7 plus a base of 10 over 2 times a height of 10. So that's going to be, let's see, 17 times 10 is 170. Half of that is going to be 85. And this is going to be in, let's see, what are the units? Meters. It's going to be in meters. All right, now for runner B, we're going to need to take the integral of the absolute value of this velocity right here. And specifically, I'm going to need the integral of absolute value of velocity from 0 to 10. So I'm going to use the calculator for this part. So here I've entered my velocity function in my y equals. I'm going to quit out now, and I'm going to math 9 this one from 0 to 10. And I'm going to do absolute value. Oops. Let's try that again. Absolute value of velocity. So that's going to be, let's see, alpha trace y1, because that's where I stored my velocity function in the calculator, and dx. And that comes out to 83.336. It's pretty close to runner A. And that's going to be in meters. For this problem, for time greater than 0, position of a particle is given by some function s, and we're told that s is increasing between 0 and 2 and decreasing for all times greater than 2. Based off that, we want to know the total distance of the particle from 0 to 5. And they're not actually going to ask us for a constant, but we at least need to know how to set it up with one of these expressions here. So in general, if I'm trying to find the total distance, there's two ways to do that. In both of them, I have to make sure that I'm adding up all positive things, so positive area. Because with velocity, sometimes you go the opposite direction, and that gives you negative distance, but we want that negative distance to count for positive. So taking a look here, if we are increasing on the interval from 0 to 2, that means we want the integral from 0 to 2 to be positive. And it's going to be the integral of s prime of t. We want the integral of the velocity of our particle here. Now, if we're decreasing after 2, then we want to subtract the integral from 2 to 5 so that that stuff that was going to come out negative actually comes out positive. In light of that, let's see what we have going on in this problem here, in this set of answer choices. So for this first one, we have the positive integral from 0 to 2, so that's good. Negative integral from 2 to 5, also good. But we have this s of 0. So s of 0, we actually don't want to know the initial position of this particle, because total distance traveled is just total distance traveled from wherever you started. We don't care where you started. So unless the s value is 0 at time 0, this is going to give us the position, not necessarily the distance. In fact, it won't even really give us the position because we're subtracting this piece of it. So this is more like the initial spot plus the total distance traveled. Not necessarily the same as the total distance. Moving on to this next one here. Well, here we have the same issue with this initial position. And also, for this one and choice C, we have the wrong integral being positive and the wrong one being negative. We want the positive integral to be from 0 to 2 and the negative one to be from 2 to 5. So that's no good. So we come down to D and E. The only difference between these, with D, the absolute value is outside the integral. With E, it's inside. And this is our other way of calculating total distance, is to take the integral of the absolute value of the velocity. So the absolute value needs to be on the inside. With choice D, our absolute value is happening too late after we've already added up a whole bunch of negative little velocity strips. So we need to force each individual little velocity, height, strip, whatever you want to call them, to be positive before we add all of them together. So we're forcing area to be positive before adding it up. So for that reason, choice E is going to give us the total distance of our particle. For this problem, we have a particle with a velocity given by e to the t going in the straight line. We want to know how far this particle moves from time 0 to time 2. Now, it's kind of ambiguous as to whether they mean, how far does it actually travel, like how many steps did it take, or what's the displacement from time 0 to time 2. But to figure out if we need to know the difference, let's take a look at our velocity function. So we notice that this function, e to the t, is positive for all t values. That means there are no direction changes for this particle, which means that total distance and displacement will be the same thing for this problem. So we just need the integral from 0 to 2 of v of t dt. So that's the antiderivative of e to the t, which is also e to the t, evaluated from 0 to 2. So this is going to be e squared minus e to the 0, or e squared minus 1, which gives us choice A. For this problem, we have a particle moving along the x-axis with a position that they're not going to give us. They're just telling us they're not going to give it to us. That's nice. The velocity, though, is given by this v of t function, and they were really nice and gave us the acceleration function as well. They didn't have to give us this. I mean, we could have figured it out on our own, but they were just nice. And we also have this initial position of x of 0 equals 2. So, first part of this problem, is the speed of the particle increasing or decreasing at time 5.5? So to figure this out, we need to figure out the velocity and the acceleration at 5.5, and then see if they have the same sign or opposite signs. So let me start by doing v of 5.5. And in order to do that, I'm actually going to plug this v function into my calculator and just plug this in there. So there's my v function plugged in as y1, and I could plug in the acceleration as y2, but I'm not sure I really need it yet. So let me get out of here. And I'm just going to do alpha trace, call up y1, and plug in 5.5, which gives us negative 0.453, and some change. Now, all we really care about here is that that's negative. So we're going to see if the acceleration is also negative or if it's positive. Acceleration, they already gave us the function actually, but we know acceleration is just v prime of 5.5. So to save a little bit of time entering this craziness on the calculator, I'm just going to go back there and I'm going to do math 8 and take the derivative with respect to x. Calculator, come back. There we go. And I'm doing alpha trace to pull up y1. So there's my velocity function. I'm taking the derivative of that at time 5.5. I think this is a little faster than plugging in directly to the acceleration. This comes out to negative 1.359. which is also negative. So we notice that v of 5.5 and a of 5.5 have the same sign, which means that our particle is speeding up at time 5.5. For this next part of the problem, I want the average velocity of the particle over the time period 0 to 6. So that's going to be 1 over the interval length, which is just 1 over 6, times the integral from 0 to 6 of, well, what are we trying to average here? The velocity. So let's just plug v of t in here right away. All right, calculator time. So here's what this looks like on the calculator. And for y1, again, that's just where I stored my velocity function that they gave me. So that is going to end up being about 1.949. For this part of the problem, we want the total distance traveled by our particle from time 0 to 6. So here we need the absolute value of velocity, and we need to integrate that from 0 to 6. So absolute value of velocity integrated 0 to 6. Calculator is going to help us with that one. So here's what this should look like on the calculator if you've stored your velocity in y1. And that comes out to, drum roll, thinking, you got this, you can do it, 12.573. For this problem, we're told that the particle changes direction once on the interval from 0 to 6. We want the position at that time. Well, let's start by figuring out where this thing changes direction. To do that, we will set our velocity function equal to 0 and see where it crosses the x-axis on the calculator. So again, I've entered velocity as my y1 on the calculator, and I'm going to set my window to be from 0 to 6 because that's where they said we're changing direction once. We don't care about any other intervals here. And graphing that out, this is our velocity. We see that it is touching the x-axis exactly once, right here. And where is that exactly? Let me do second trace and do 0 to figure that out. And I'll just enter in 5 and 6 right away directly, so I don't have to mess around moving my little spider cursor there. So that happens at about 5.1955. And I'm going to store that as A on my calculator. So I'll quit out of there, and I'll press store, and then alpha A. And now I can just pull that back whenever I want. So I'm just going to write here that v of t changes sign at t equals a. So our particle changes direction there. So we have to prove that we actually do have a direction change there. Next, to find the position, I'm going to do my initial position of 2 plus the integral from 0 to a of my velocity. And I'll use the calculator for this. So we've got 2 plus math 9, integral from 0 to alpha a. Now that a value is coming in handy. And I'll use y1, so alpha trace y1 for my velocity there, dx. And that all comes out to about 14.135 if I round that off.